kind of figure it's right around 5,400 feet, maybe 5,395. And visually, it's not going to appear much taller than that because here's what the top looks like. So these are very low shrubs, maybe 3-4 feet tall. So you can walk around up on the top of Graybeard Mountain and you're just going to have a clear view, 360 degrees. So they add maybe 5 feet onto the top, visually speaking. So Frying Pan Mountain here on summitpost.org is 5,340, and again I've seen it from 5,320, maybe 5,330, all the way up to 5,370. So I take 5,340 or 5,350 as an average. And there are large trees. So this is the trail going up to the summit, and this is not far below the summit at all. The trail is actually quite short, and it looks like this the whole way up to the top and over all the way to the tower. And here's a shot of the tower. You can see the trees all around it. I estimate those trees to probably be 40 feet tall. So if it's 5,340 or 5,350 and you have 40-foot tall trees, then you end up with, visually it's going to appear about the same as Graybeard Mountain and about the same as my camera position. And to verify the 770-foot number that I referenced, I'm going to use some mainstream sources for Earth curvature. This is DizHub, as you can see. It's a heavily used Earth curvature calculator by flat earthers and others as well. We're going to put in our numbers here. Our eye height is the height that we are above what we are observing. And that's going to be 0 because the test that I designed incorporates 3 equal heights. So that'll be 0. It would be the same as if your camera was exactly at sea level and you were recording straight out across the water. So your camera is level or 0 feet above what is being observed, which is the ocean in that case. And the same would be true for a camera at 10 feet above sea level. Imagine you're filming objects floating in the water that are 10 feet tall. Well, the camera would be 0 feet above the tops of the floating objects. So the eye height here would be 0. And our target distance is 34 miles. If I calculate that, we get 770 feet, which is exactly the amount of declination I said we would have. And here I have another Earth curvature calculator. Just to verify this, I put in 34 miles as the distance, and the height of the observer above what is being viewed again is 0, and I calculate the hidden amount, which is the same as saying the declination, and it's 770 feet. So again, that matches the number that I provided. And then here we have one more website. I just wanted a few sources here to validate my number. This is someone who's not a flat earther. It's actually a math website. He's talking about the formula for the Earth's curvature. Here's what he says here, that flat earthers often claim that the curvature of the Earth's surface is 8 inches per mile squared. That's true enough over distances of several miles, and that the horizon should therefore have a noticeable curvature when viewed from low altitudes. He's basically saying that you wouldn't be able to see it. But he does use this formula, which is 8 inches per mile squared. If you go here, and I use that formula, so it's 8 inches times the mile squared, so 34 times 34 gives us the declination in inches, because we were calculating in inches there. And then if we divide by 12, we get the declination in feet. 770 feet again. I just wanted to confirm that my figure of 770 feet is an accepted mainstream number based on the accepted formula for the curvature of the surface of the Earth. Here's a topographic map of the area where we conducted the test. This is the Blue Ridge Parkway, and this is the turnoff to the Shining Rock Wilderness. Our main trail that we took in was the Ivester Gap Trail. What we were really trying to do was get around in front of Tennant Mountain. And I'll zoom in here. The reason for this is that Tennant Mountain is in a line with Frying Pan Mountain and Graybeard Mountain. But it's 6,040 feet tall. So it's too tall to conduct a test from the summit. The idea was to get around to the front and get down to 5,380 feet in order to do the test. So the first two attempts we made were off of the Ivester Gap Trail down this purple trail. You can see here the trail runs just under the 5,600 foot interval at about 5,500 feet. So I dropped down from the trail about 120 feet and I went back and forth on this mountainside trying to get a view down this line of sight towards Frying Pan Mountain and Graybeard Mountain. The problem was, though, is that it was either this ridge or this ridge, I didn't know which at the time, or maybe even one further out front was getting in the way of the shot. We went up here twice in this area until eventually we just had to give up because I could not get a view. Then we decided to continue out on the Ivester Gap Trail. These purple trails denote our failed attempts, so this was our second failed attempt. The problem with this trail was that by the time we got to the line of sight, the trail had descended to about 5,300 feet, which was just too low for the test. As we were trekking around the mountainsides here, we came to realize that this ridge that didn't have a trail was most likely the one that was blocking my view, and also where I would get the shot. So we set up a little base camp, approximately 20 feet below the trail. Here's our little base camp, you can see. And here's the altimeter, which verifies that we were at 5,670 feet, which is just about right. Because if you look at the topo map here, you've got 5,600 feet. 40 feet for each interval would be 5,640, 5,680. The trail's at about 5,690, and 5,670 would be just about right at 20 feet below the trail. Wisely, my wife decided not to go bushwhacking with me down the mountainside. That was a really good decision. It was extremely difficult. She waited for me here at the base camp, and I started just going down this ridge, trying to find a clearing. Initially I was trying to find a clearing, someplace I could set up a tripod that I'd been carrying with me. Eventually I came to realize that was never going to happen because the shrubs were never less than about 10 feet tall. This actually took me 3 separate tries. So I went down this trail that I made down the mountainside and made 3 different attempts to find the location to make the shot. And we actually came out here to this base camp and went through this whole process 3 different times. What I was doing was I was just moving back and forth on the hillside, just always looking for a clearing and trying to get that view until I finally realized I was never going to get a view on the ground and I had to start climbing trees. I would say I probably climbed about 15 trees altogether until finally on our 3rd trip I found the tree that was at the right elevation and on the line of sight. Luckily I had the tree saw, which you saw at our base camp, because what I realized was that if you climb up in a tree and it's at the right elevation and you have a good line of sight, you're sitting in the middle of the tree, the branches are all sticking out and blocking your view. But luckily I did find the right tree and I was able to cut away the branches and conduct the test, record the observation, and you will see that shortly. Here's another piece of data I'd like to share. This is a website called Peak Finder, which surprisingly I did not discover until about 3 weeks ago. This would have been really helpful in locating the mountains to do the test. I actually used to go up to Shining Rock Wilderness and look around at all of the distant mountains and wonder how I could identify them. I had actually even gone to a lot of different websites trying to find a way to identify mountain peaks. I'd gone to a site called Peakware and Peakery and probably several others, and just happened to miss this site. But anyway, this is going to be really valuable for us right now because this site is going to validate my claim as to which mountains we're looking at. So you can see here that this is the view from Tennant Mountain, which is correct because we're on a ridge slightly below the summit of Tennant Mountain. This is a really amazing technology in that you can virtually stand on top of most mountains in the world as long as they're recorded, and you can spin around 360 degrees. If you use this binocular tool here, you can actually click on almost all of the mountains around you, and you will get the elevation and the distance from you and the direction to that mountain. If we zoom all the way out here, you can see this is most likely the ridge we were on, and I was somewhere right about here. And this is probably the first ridge we were on in which my view was obscured. If we zoom in again, you can see that this is most likely the third attempt we made down this ridge, and this trail just dropped too quickly and our elevation ended up being too low. If you look here, you can see the mountains that will be in the shot and look very similar to this. So here's Frying Pan Mountain, here's Graybeard, the two primary subjects of the observation. Here's Pinnacle, which is also in the shot. Here's Mount Pisgah. Again, every website has slightly different elevations. So this website has 5,318 feet for Frying Pan Mountain, which is a lower elevation than I had claimed previously, but at the same time this website lists Graybeard as 5,364 feet. So that's only 46 feet of difference between the two. Okay, so that's it for the subject of the test. One other thing I did want to show you is if you look over here at this mountain, this is Little Pisgah Mountain. It's listed as 5285 on this website, and Frying Pan is listed as 5318. Most resources for elevations are going to show different elevations for Frying Pan Mountain and Little Mount Pisgah, but the difference is almost always going to be about 30 to 40 feet. So Little Mount Pisgah is always going to be listed as about 30 to 40 feet shorter. And if you look here, you can see that the distance to Frying Pan Mountain is listed as 6.6 miles, and the distance to Little Mount Pisgah is 9.2. If we turn off the binoculars, notice that if you draw a horizontal line across here, Little Mount Pisgah is up higher in the shot than Frying Pan Mountain, because the shot is from the top of Tennant Mountain, which is 6,040 feet. So when you look at the shot that I got, you will see that Little Mount Pisgah appears shorter than Frying Pan Mountain. So the shot actually validates my claim as to the elevation of the camera. Because if I were, say, 50 or 100 feet higher than I claim that I am, which I was at different times, then Little Mount Pisgah would appear taller than Frying Pan Mountain. And it clearly does not in this shot. It's very evident that Little Mount Pisgah, which is further away from the camera than Frying Pan Mountain and slightly lower, does very clearly appear slightly lower. The shot is actually validating my claim about the elevation of the camera. And we have Peak Finder, which is very clearly validating my claim about which mountains we're looking at. Here's a little model I made of Frying Pan Mountain and Little Mount Pisgah to illustrate the concept of the camera elevation really impacting what you see with regard to the perceived height of foreground and background mountains. So you see as the camera moves up, Little Mount Pisgah appears to be taller than Frying Pan Mountain, and if you keep the camera level with the top of Frying Pan Mountain, then Little Mount Pisgah is obscured, and it would appear lower off to the side as it is in this shot. So you can see the camera moves up and it becomes visible, the camera moves down to level with Frying Pan and it's no longer visible. Even here when it's off to the side, it's clearly lower than Frying Pan Mountain, which is exactly as it appears in the video. The distance from camera to Frying Pan Mountain is just about 6 miles, and Frying Pan to Little Mount Pisgah is 3 miles, which is half. So if I were to raise the camera up 100 feet, it would cause Little Mount Pisgah to visually raise up half of that 100 feet, which would be 50 feet. Seeing as how it's only 30 feet lower than Frying Pan Mountain, it would appear to be taller, and it does not appear to be taller in the shot. It clearly appears to be lower, just exactly as it is. The same would apply if I were to, say, have the camera 60 feet higher than what I'm claiming. Then again, at that point, because Little Mount Pisgah is about 30 feet shorter than Frying Pan, it's going to appear to be level with Frying Pan, and in the shot it appears clearly to be